All right, chapter 3-4, solving equations of logs and exponentials. Now, I give you the example, e to the x equals 72. The opposite of an exponential is what? Sorry? Nope. The opposite of an exponential function is what type of function? Is it? A logarithm. The opposite of an exponential is a logarithm. The opposite of a logarithm is exponential. They undo each other just like multiplication, division, undoing one another. Yes? Okay, so I have e to the x equals 72. If I have e to the x equals 72, I have to get the x out of the exponent position. Because I can't solve for x whenever it's in the exponent position. The way we're going to do that is by simply taking the log of both sides of this base. So log base e of e to the x equals log base e of 72. Yes? Log base e is the natural log, which is what I would have rather seen everybody understand, right? But I wrote that just to get us back into the habit, right? What happens to the natural log of e? They do cancel. So these cancel out. I have x is equal to the natural log of 72. Yes? Now, if I go over to my calculator, and I type that in, I have the natural log of 72. What is that going to be? 4.277. 4.277. Do we understand that, yes or no? We good? Okay, can anybody remember how we wrote this as a natural log before? If I had e to the x is equal to 72, how do we write this as a logarithm? Log base e 72 is equal to the exponent. So this was the natural log of 72 is equal to x. Isn't that what that was? Remember when you go back and forth between a logarithm and a natural and an exponential, you're able to think differently. So that's exactly what you did there. Okay? And I showed you how to solve it. Same exact concept. So how do I solve this? 3 times 2 to the x is equal to 42. What would you do first? I need to get the base, which is 2 to the x, by itself. Isolate that. So what do I have to get rid of if I'm isolating the exponential part? Divide by 3, right? So if I'm going to divide both sides by 3, I have 2 to the x is equal to, what's 42 divided by 3? 14. So now, how do I get rid of the exponential? I am going to take the log of both sides of the base that I currently have. So what is the base of this exponential function? 2. So I'm going to have log base 2 of 2 to the x is equal to log base 2 of 14. Do we all see that, yes or no? What happens to the log base 2 of 2? Cancels out, and I'm left with x is equal to log base 2 of 14. So that means if I come over to my graphing calculator and I type that in, I hit Control 10 to the x. I'm going to go ahead and put a 2 there for the base, arrow to the right, and make this a 14, and hit Enter. And that's going to be 3.807. Yes? Do we all understand that? We good? Okay, next. How do I do this one? Add the 3 over. Sounds great. 4e to the 2x is equal to 5. Then what? Yep, divide by 4. E to the 2x is equal to 5 over 4. Now what? I'm sorry? take the natural log of both sides because that is the base. Those cancel out, and you're going to be left with the 2x is equal to the natural log of 5 over 4. Now what? What do you think? How do I solve that for x?
Could you divide by 2?
Absolutely. I need your brains to understand that this right here, that's just a number. It's just it's a numerical calculation, correct? It looks nasty to your brains, but it is still just a numerical calculation. We're simply going to take that calculation and divide it by 2. So x is equal to the natural log of 5 over 4, all divided by 2. So if I go over to my graphing calculator and plug that in, I have control e to the x, so that's not do it for me. Control e to the x, 5 divided by 4, arrow to the right to get out of there, divide that by 2, and you're going to get the 0.112. 0.112. Absolutely, you could do that too. It's completely fine if you go ahead and do this in simple parts here. So this is going to be Control E, 5 divided by 4, hit enter, then take that and divide it by 2. It's going to give you the same exact thing. You with me? It's still the same calculation. All right? Any questions over that? Excellent. Okay, let's keep going. What do you think about this one? I'm sorry? I probably would not. Anybody know why I would not do that? Look at it from this perspective. What if I already have this? What would you do? You would put that into 2 binomials. What we have are 3 terms up there. When you have 3 terms up there, you want to treat it as though you would have not exponential functions, but just quadratic functions where you would put it into 2 binomials together. Does that make sense? So instead of looking at the green, we're going to go back and look at the blue. And I have to break down e to the 2x. So how do I break down e to the 2x? E to the x and e to the x. Does that make sense? Yes? Okay, now, how do I break up the factors of 2? What is 2? 2 and 1. Then I need it to be a positive 2 but a negative 3, so that's why both of them are negative. Yes? So this is going to be e to the x minus 2 is equal to 0, and e to the x minus 1 is equal to 0. So this is e to the x is equal to 2, and e to the x is equal to 1. Now, how do I solve these? I'm going to take the natural log of both sides. So the natural log of both sides says that x is equal to the natural log of 2. So x is equal to the natural log of 1. Now, you're going to come over to your calculator, and you're going to type those numbers in. We already know that the natural log of 1 is always and forever 0. And the natural log of 2 is going to be 0.693. So we have our 2 answers there. Do we understand that, yes or no? Okay. Okay, now let's move to the other direction. We're going from exponential equations to logarithmic equations. So, you guys already know this. Our brains don't work in logarithms, do they? What do they work better in? Exponentials. So if I wanted to write this thing as an exponential, how would I go about that?
E squared equals x.
This is log base e of x is equal to 2, so that's e squared is equal to x. He's absolutely right. What is e squared? It's a number, right? So calculate that. What is e squared in your calculator? Do we all understand that, yes or no? Okay, now that was just you writing it as an exponential and solving the exponential. Now let's say our brain is not going to do it like that. I'm going to delete this, and we're going to do it the other way. What is the base of that logarithm currently? So what we're going to do is we're going to have e to the natural log of x is equal to e squared. Those cancel out, x is equal to e squared, which is the 7 point, what was it? Does that make sense? Okay. Keep going. What do we do with this problem? What's your gut telling you? These cancel out. So I have 5x minus 1 is equal to x plus 7. Now what? How do I solve that? Subtract the x, add the 1. I have a 4x is equal to an 8, so x is equal to 2. Now, when you do this, you have to be a little bit cautious, okay? And here's why you have to be cautious. You have to think about domain restrictions. The logarithmic equation does not even begin unless it's a value for x that is greater than 0. Do we all understand that? Yes? You cannot take the logarithm of a negative number because it's not defined on the negative number system. Yes? Do we understand that? So if I plug this back in, 5 times 2 minus 1, that's 10, take away 1, which is the 9. Can I take the logarithm of 9? Yes. Over here, this is going to be 2 plus 7, which is 9. And again, I can go ahead and take a logarithm of a positive number 9, so I know I'm okay. So that means this is in the domain. I am okay. I don't have to worry about it. Do you all understand that? Okay, what about this one right here? What do you think we should do there? I'm sorry? Subtract the 5. Sounds great to me. 2 natural log of x is equal to negative 1. Now what? That's 2 seems out of place. What should you do with it? No, you're trying to condense. How's it attached to the logarithm currently? So we're going to divide both sides by it because we just want to isolate the natural log, right? You don't want to know what number that was that I wrote right there. X is equal to, or I should say the natural log of x is equal to negative 1/2. Now what? Not the natural log. So this is e to the natural log of x is equal to e to the negative 1/2. Those cancel out, and x is equal to e to the negative 1/2. What is e to the negative 1/2? E is just a number, yes? Since e is just a number, all you have to do is actually plug that in. So what is e to the negative 1/2? What number is it? 0.607, yes? We good? What do I do here? What do you think? Yep. I would divide both sides by 2. Log base 5 of 3 to the x, or not 3 to the x, it's 3 times x, sorry, is equal to 2. Now what? So your brain wants to write this as an exponent. That's fine. Same thing, right? $25 is equal to 3x. Divide by 3. 25 over 3 is equal to x. Do we understand that, yes or no? You good? Okay. What we've talked about tonight's homework, and I'll get you started on it. You guys should have lots of time to get busy on it. I have to do the answer. I lost it. No idea what I've done with it. I'll find it after I have to do it. Don't worry. The way it always is. Okay, we're going to do number 6 together. Now, if you look at number 6 on your paper, what do you notice about number 6? Sorry.
A lot of natural logs.
There's a lot of natural logs. How many are on the left-hand side?
2.
Left-hand side.
Right.
On the left-hand side, there's 1. On the right-hand side, there are 2. We all understand that. Okay? I can't cancel out my logarithms unless it's 1 natural log equals to 1 natural log. We all understand that. So what I have to do on my right-hand side is I have to condense that down into 1 logarithm. So in log world, those 2 logs are attached by subtraction. So what does that mean in log world? Division. So what we're actually going to have here is the natural log of x plus 5 is equal to the natural log of x minus 1 over x plus 1. Do we all see that, yes or no? You good? Okay, now, what can you tell me about that? What can we do now? Okay, so if you cancel this out, we have x plus 5 is equal to x minus 1 over x plus 1. How would you solve this? How would you solve this? Well, could you cross multiply? Sure, or just multiply both sides by x plus 1. That's the same thing. And then what would you do now with those 2 parentheses? FOIL that. So that's an x squared plus a 5x plus an x plus a 5 is equal to x minus 1. What do you think you do next? I would combine like terms to give me a 6x plus 5 is equal to x minus 1. Then what would you do? I'm going to subtract x and add 1. So I have x squared plus a 5x plus a 6 is equal to 0. 2 binomials. X and x, 2 and 3 are going to add to 5, and they both have to be positive. So what does that imply x equals? X equals -2 and x equals -3. Now, what did I tell you that you had to be careful of? You have to be careful that whenever you plug in a negative into your x value, that natural log is of a positive number, right? So if I mentally plug this in, I'm going to go ahead and have a -3 plus 5. That gives me a +2. I'm okay there. A -3 minus 1 is going to give me a -4. Ooh, that's a problem. Can you take the natural log of that? No. What about -2 minus 1? Can I take the natural log of that? No. So what that implies is neither one of those are actual answers. They're extraneous solutions, so my only answer is no solution. Do we get that? Yes or no? When in doubt, graph it out to determine that, and you'll be able to see that immediately. Do we all understand that? Yes or no? Okay, I'm going to give you guys the rest of the time to start this. You guys should have a good idea what you're doing. I will sit up here and do the answer sheet because, yes, I can't find it. Okay?